Our project is called the Pixel Forge. It is a GPU accelerated image processors project using CUDA. The main idea is to take an image and apply filters to it, but instead of using the CPU. Also, use the GPU to compare the performance. We wanted to see which image filters come faster when thousands of GPU threads work at the same time, in other words. Pixel 4 is an image processing program made with CUDA and OpenCV. OpenCV help us to load and save images, while the CUDA let us run the code on a GPU. The program applies filters like grayscale, blur, edge detection, and pixel. Then we compare the CPU version against the GPU version to see which one's faster. The main goal is to show that the GPU parallelism can make certain things like image filters so much faster, especially when filters has a lot of work per pixel. In other words, the CPU usually processes pixels one after the other, like going through a line. The GPU works differently. It can process many pixels at the same time. In our project, the image is copied into the GPU memory. Then a CUDA kernel runs where many of threads work on different pixels. After the GPU finishes, it processes the image and copies it back to the CPU. This works because most pixel calculation is not dependent on each other. For example, one pixel could turn gray without needing to wait for the other pixel, if that makes sense. Whereas the CPU has to wait. Pretty much this slide shows how each CUDA thread finds the pixel it is responsible for. It's just a formula of finding the X and Y position of the pixel and tell us which block are in and how big is the block. In, instead of sending the CPU process one pixel, then 2 pixels and 3 pixel, we will let the GPU assign many threads and many pixels at the same time if it wants, in other words. And each thread gets 1 pixel, does the filter calculation, then writes the result back to the output image. So the first filter that we implemented was the grayscale filter. Changes the colored image into black, white, and gray shades. For each pixel, we take the red, green, and blue values, averages them, and we set all three colors channels into that same average value. This is easy to parallel because each pixel can be handled independently, but the grayscale is also very simple, so the GPU doesn't always win here. In other words, the time spent copying the image to the GPU is launching the kernel can be more expensive than the actual grayscale math. And the second filter we did was blur. The blur filter is more expensive than the grayscale because each pixel needs to look the nearby pixels. So we use a 7x7 box blur, meaning each pixel looks up to 49 surrounding pixels, average the colors, and use the average as a new color. This smooths out the image and makes sharp edges less noticeable, in other words. This is where the GPU is so much better because many pixels has so much work to do since the GPU can process many pixels at once. The third filter we did was the edge detection. The edge detection, we use a Sobel operator. This filter finds the brightness changes from top to bottom and left to right. And then using the Sobel method, it uses a 3x3 matrix. One checks horizontally and the other checks vertical. For each pixel that surrounds each pixel that surrounds pixels are converted into grayscale, multiply the Sobel values, then combine to decide how strong the edge is. The bright pixels in Apple mean strong edges, the dark pixel means little to no edges. Then the last filter we did was pixel. The pixel filter makes the image look more blocky or retro, like Minecraft would be example. It splits the image into square blocks. Then on each block it calculates the average of red, green, blue color. After that, every pixel inside the block gets the same average color. A bigger block size makes the image look more pixelated. The smaller block size keeps it more detail. This works well on the GPU because it different blocks or pixels can be processed at the same time. Our variation pretty much it just shows the time compared to the CPU with the GPU. On the grayscale, the CPU is much faster because the operation is simple, where the GPU has to spend extra copying the memory, launching the kernel, and then copying it back. But when it comes to calculation, it's faster, but it just took so much time. For the blur, the GPU is so much faster because each pixel has to check 49 nearby pixels. That gives enough time, enough GPU to work and to show its strength. In other words, the edge detection is also faster on the GPU side because of each pixel use neighbors pixels and the sample math, and also the pixel is faster as well on the GPU because the work that's split between cross many blocks and pixel, which pretty much shows the GPU is faster. And then the biggest thing that we learned that the GPU is not automatically faster for every task. For simple filters like grayscale, the CPU can be faster. The work is too small because the work is too small, and the GPU setup is overhead and too large. In other words, as the filter becomes more complex, like blur, edge detection, and pixel, the GPU becomes faster. This shows the trade-off in GPU programming. Using the GPU is worth it when the parallel work is large enough, in other words. And then we will go off to our demo. So how the algorithm runs is we have to run this program, this line in the terminal to activate the open CPU or else it would run. As right now, so I rerun it and make clean to make sure everything runs. Normally over here on this Apple folder, it will show all our outputs. So what we have at the moment is our images that we have. But the only image we're using is the cute one. That's the only thing we're going to use. That's the one we're going to show. So we run make an executable. And then once we run the pixel executable, once we run the code, it shows all the times compared to GPU or CPU. Where like what I was telling you, where the on the gray filter the GPU is slower because it has to copy, launch the kernel, and all that type of stuff. Where over here, where the GPU outperforms at all the CPU. Then on the folder here, the output it shows all our on our GPU and CPU. Pretty much the GPU pixel, same thing. GPU black and grayscale, same as CPU. GPU edge, which is comparing all of it, and